So in section 13.3 we're talking about finding functions, and it would work like this. If I have dy by dx, then I know about the gradient of a function. Dy by dx might be, let's keep this simple, might be x squared. So the function would be 1/3 x cubed plus a constant, okay? So 1/3 x cubed, if that constant was 0, then 1/3 x cubed would look something like that, okay? Now, that constant might not be 0, it might be 1. So 1/3 x cubed plus 1 would just be taking that and shifting it up the y-axis. 1/3 x cubed, that constant could be 6, in which case I'd shift that up the y-axis any further. And you can see that what's happening is that constant changes. We're taking the same function and we're sliding it up and down the y-axis. So it could be that shaped curve. The integral of this, if that was the derivative, the function has to be this curve slid up and down somewhere or other. Okay, so I just don't know the height of it, but I do know the shape of it and everything else. And if you think about it, that's because if I give you an x value, the derivative is the gradient. So if I know the gradient at this x value, what I don't know is the height of the function, but I do know the steepness of the function. And then I know that the same thing for the next x value. I know the steepness of the function, but not the height of the function. So I know the shape. If I know the derivative, I know the shape, but I don't know exactly where the shape is. So that sort of makes sense if we stop and think about it for a bit. So if I want to find a particular function out of all of these, I need to find the c. So if I knew this was y equals 1/3 x cubed plus 7, then I'd know which of these many functions it could be. But this way we might call, it's often referred to as a family of functions, all right? So which of these family of functions did we have? And, well, if you look at the equation, I've got y, x, and c. Well, if I told you one coordinate that was on this curve, so if I told you this was one, actually it can be anything, can't it? So if I said this was 1, 7 was on this curve, then you could say, right, well, this is the curve when x is 1, y is 7. So let's substitute the 7 in for y. 1/3 times 1 cubed, well, 1 cubed is 1, so 1/3 times 1 plus c. So 7 equals 1/3 plus c, so c must be 6 2/3. Okay, so if I told you that this curve goes through that point, then you can tell me, well, the curve that you actually have then isn't just one of these family of functions, but it's this one specifically, okay? Now, if you look at example 6, they've done exactly the same steps, but they've done it with a slightly more complicated function. I've just kept the first function slightly simpler. If example 6 is confusing, you go back to section 13.1 and 13.2 and check that you understand how to do the integration, and then look through this example and you'll see that all of the steps there are exactly the same. The last thing to say is, it makes sense that if I tell you a point that this curve goes through, I should be able to find the curve exactly, because if I pick a point here, well, there's only one of these curves, one of this family of functions, which is going to go through that point. So having a point is enough to know, to find out the constant. You know, it should be, and it doesn't have to be a point here. It could be any point on the whole grid. If I just give you one set of coordinates, that's enough to find the curve that we were dealing with. So that's what we need to do in exercise 13C. By the time you get through exercises 13A, B, and C, you should have done a lot of integrating. And it is worth doing that practice, because when you head off into the rest of the chapter, you're going to use integration to solve other problems. So you need to be able to do the integration without thinking and concentrate on the bigger problem of finding areas under curves or whatever else it is. So although integration in year 2 gets really quite nasty, if you just put enough practice in at this point, the first year integration is relatively straightforward, I think. Doesn't mean it's easy, just straightforward in the sense of do enough practice and you'll get the idea, okay?